first problem we're going to do in Haskell. It's called sentence smash. We're going to write a function that takes an array of words and smashes them together into a sentence and returns the sentence. You can ignore any need to sanitize words or add punctuation, but you should add spaces between each word. Be careful, there shouldn't be a space at the end, at the beginning, or the end. Okay, so they give us one example. Let's take this and I always like to kind of mess around with the example. What is all that? Not sure. Okay, so basically we're going to take a list of strings as an input and we're going to return a concatenated string. So the plan here is to kind of do this in Python or just some pseudocode and then translate that to Haskell. So how would we do this? Just talking about it, we could iterate over every element in the list and add it to some like accumulator that starts out empty. So you could go for string in strings accumulator plus equals string, and then we'd return the accumulator. That's how you would do it in Python. Let's see if we could do it in a recursive way, a recursive function. So this would be iterative, like using loops, basically. That's what that means. One after the other. Let's see if we can do it recursively. Let's see. So the base case. So what happens if we have like an empty string? We'll say if, let's say def smash x's x if len of x is 0. Or what would we do there? We would just return an empty string. And then what if it's 1? Then we would just return x. Like say we had a list of just hello. Then we would just return hello. Okay. Otherwise, what are we going to do? Say we have, so once we get past these two if statements, now we know we have more than one element. So what are we going to do here if we have more than one element? We're going to return the first element. And how do you I forgot how to do this in Python. How do you concatenate strings in Python? A plus B. Yeah, that works. Okay. We're going to add the first element to smash. Well, we want a space plus smash of the remainder. So, yeah. And so that's kind of hard to wrap your head around. So let's walk through an example. Let's say our input is A, B, C. And then let's see what happens as we walk through this function. Okay, so input. Let's just keep track of what's going on because we're going to have like a stack. Let's say the call stack. This is our call stack. So first we're going to call smash on this thing. Okay, so what happens here? We're going to get to this point here. So we're going to return A space plus smash of B plus C, right? Right, so return the first one plus a space plus smash of the remainder of the tail. Okay, so we now have this plus this, and so smash of BC, what happens here? This is going to return, let's see, the first element, so B plus a space plus smash of the last element. So the next is, this is kind of a call stack, it's kind of not. Okay, plus, what is this going to be? B space plus smash C. The first element plus a space plus smash of the tail. The tail is, the remainder is just C. So now we've got A space plus B space plus smash of one element. So now we do smash again, and now the length is 1, so we're just going to return C. So then this becomes which equals oops, ABC. Okay, so I think this works. So now let's see if we can translate this to Haskell. So in Haskell, we do smash, and we can do a type signature. So it tells us like what types our inputs and outputs will be. So we're going to take a list of strings and we're going to return a string. So smash, this is our input. This is how we say our input. We'll say our input is X. And so we're going to do pattern matching in this case. And so we're going to say case L of, we're going to say when L is an empty list, you know, when the length is, that's the same thing as this. We want to return just an empty string. And when we have one element, we want to return that element. And when we have a list with multiple values, we want to do the head plus a space plus, we're going to call smash on the remainder, on the tail. So this is doing the same thing as this in Python. So this is recursive Python. Let's move this out of the way. So scratch, recursive, and then Haskell, recursive Haskell. So let's walk through that example again using Haskell. So say we have smash of, oh, I shouldn't have deleted it, that's okay. Get some typing help, typing practice. Okay, so say we call smash on ABC, what's going to happen? It's going to pattern match on this guy here. So we're going to have A plus a space, and then we're going to call smash on the tail, so BC. So now we have smash BC, and so it's going to match again with the multiple elements in a list. And so then this is going to become A plus now B plus a space. Okay, so when we do smash BC, we add B with a space with smash of the tail. So now we're smashing C. And when we have one element, we're just going to return that element. Okay, so now we have okay, so and this works out. We don't have the like remainder space on the end. Only the first two have spaces. So that's how that works in Haskell. To me, that's actually a little bit clearer. Like I look at this and it's just much easier for me to see what's going on compared to this. Like this is like kind of hard to follow what's happening here. And I have way more experience with Python than Haskell, and even still, this is just simpler to see, at least for me. But let's just confirm this works. We can put this in here, run it. Uh-oh, what do we do wrong here? Failed to detect module name. Oh, I didn't, I think this, wait, hold on. Oh yeah. I deleted this thing. Okay, so let's see if that works. Let's variable not in scope. Oh, because this is supposed to be X. Case X of I think this has to be, so these have to be different here. So this can be L, this just has to be L. Like this is kind of like a lambda function. So these are referring to different things. In this case, the whole thing here is L, the whole thing here is L, the whole thing here is L. Yeah, I think that was the issue. Okay, there you go. We learned a little bit about pattern matching, recursive functions, translating between Python and Haskell. Feel free to stay tuned for the next one. See you guys.